Hello, and welcome to our last Q&A session in our Deep Learning course. Thank you for joining. This is going to cover our Torch session that we had last week. And we have a number of experts on the line to help. I know this class is scheduled for an hour. We're only going to be able to do 30 minutes today due to a number of conflicts with our experts. So we'll try to get as many questions as we can answered in that time. So as before, please ask your questions over chat, and then we will be answering those as fast as we can. In addition, Allison, who presented last week, will also be reading through some various questions and answering them verbally over the audio when we get started. I do want to call out that we have another course starting here in a week or two, or it's actually the beginning of October, for OpenACC. I will put the link in the chat. So if you enjoyed this course and are interested in learning about OpenACC, I encourage you to register for that. We also have supercomputing coming up in Austin. In our NVIDIA booth, again, as we usually do, we will have labs available there as well. So you can, if you're at the conference, you can just come to our booth and take a 45-minute lab and learn something new about GPU computing. And then also we are now starting to take submissions for labs at GTC, our GPU Technology Conference next April. So if you're interested in actually creating a lab on your technology using GPUs and presenting it to the attendees, you can do a submission through our system now. So please start sending in your questions, and I will turn this over to Allison. And again, this is only going to be for 30 minutes. Apologize for the short notice, but we have a bunch of other stuff going on today, so that's as much time as we could get from all our experts. All right, thank you. Allison, want to go ahead?
Yeah, hi, and welcome everyone again. Thanks for coming back for the office hours. So what I'm going to start to do while I'm assuming people are sending in their questions over chat, and my colleagues will be busily answering those, is I will start to read out and then answer some of the questions that we've already had and that my colleagues are furiously answering for you, and obviously I'll try and answer some myself. So I'm actually in central London today, so you may hear a small amount of traffic, but hopefully the audio is really good. So let's begin then. This is a question. In Torch, how does 1D convolution in the NN package, how does it work? I don't see where I could set the number of filters. So I would suggest that you try using the 2D convolution with 1 as the secondary dimension. And the actual end documentation is available upon the master's Torch NN GitHub. How is it possible to layer-wise pre-train a neural network in Torch? So doing true pre-training with generative models is more advanced for most users. Transfer learning is available. This is so far as cafe models. Load up the models, click the link to the model zoo. But the cafe import does not cleanly import. Okay, obviously this is, bearing in mind we're talking on the cafe here. But import the models, and the basic units need to be connected correctly once imported, and also check the primary literature. Again, if you go to the main github.com/torch/torch7 wiki, there's a bit more information on that. Is distributed MPI-like neural network training available in Torch to offload computation to multi-GPU clusters? There is support for multi-GPU training within Node, but currently no inter-node support. Is digits more likely to support, I think I actually answered this last week, but more likely to support Torch Next or Theano? Definitely Torch, although we are working on a number of different frameworks, but actively developing the Torch version for digits. So you can expect that next in the next possibly around 2 months. Okay, somebody said, I was hoping to learn about what Torch is and how the class seems more oriented towards people who already know Torch. It is difficult to gauge the advanced percentages of viewers. So I kind of took an image here. But if you go to the cheat sheet, and obviously I leave a page on the main website page. If you go to the cheat sheet, then that really does help you begin as a beginner. It starts from scratch. So I'm hoping that might answer that question for you. Maybe there is somewhere to find out a bit more. Yeah, definitely. I mean, also go through the slides that are now available and have been since last week on the whole presentation from last week. So there's a lot of resources that you can go to on that. Again, the Google Groups is best for beginners and install problems. If you are more advanced, you can head over to Gitter to ask more there. And there's a GitHub issues, tutorials and instructions, etc. Or just start with the cheat sheet. Okay, so what is the name of the system used for pedestrian detection? Okay, I covered this one last week. If you go to Soumith's own website, which is actually just Soumith, SOUMITH.ch, he actually has a section on pedestrian from CVPR 13, and there's very probably a section for this year's CVPR slides as well. Can we run torch models or code through Python? Yes, that can be done with lib. Is there a preference of Titan X over Tesla K20 or K40? This is obviously a big question, but it really depends on what level of training you're at. If you are just developing your code, if you're just playing around, then Titan X does, definitely is a great board to start with. It also benefits obviously from the Maxwell architecture, and it's just a really good development workstation. But it's not intended to be used in a server or a data center. So at that point, if you have K20s, then obviously those boards are great for deploying on. Alternatively, I was personally using a K40. K80 is effectively 2 GPUs on one board, so you're going from 2,880 cores to double that, and double the bandwidth as well. So of course, you're getting the doubling in performance, but when you also bear in mind that we've now effectively doubled performance again just by our software upgrades. QDNN is now version 3, for example, then it's all going to work out really well into the deployment side. But again, if you're just doing developing, Titan X is perfectly adequate. Okay, in the CPU-GPU comparison, does the CPU use the vector operations? This usually gives a 16 times speed up. Several operations are performed by the GPU, not only vector but also matrix operations, which are at the base of the convolutions. To perform vector or matrix operations on the CPU, you can also use BLAS or MKO. Another question here, that's actually again on the subject of the pedestrian detection, that Soumith details in his soumith.ch website. There's lots of resources there. Okay, bear with me, just scrolling through here. So what is the difference between the NN and the FDNN modules released by Facebook? The FD is literally just Facebook owning. It's their code as opposed to specific Torch code. Torch was, as I said, started out with Ronan Colabert, and it's now Roland Colabert, Facebook, Corey of Google DeepMind, Clement Farabee of Twitter, and Soumith is also Facebook. So there's a lot of overlapping, but it's effectively the same function. Facebook released the plugin for Torch that added the number of new features and optimizations in addition to the original Torch NN module. Some particular examples: they added a version of the FFT, Fast Fourier Transform implementation for convolutional layers. That was in, I believe, January, when they first open sourced their FP code, and it was the fastest FFT out there. Now that's possibly not valid any longer because things are happening very quick. And they also provided multi-GPU support for Torch. But again, Facebook is very much integrated. You know, it is seamless. That's running the Android side. They also provided data structures, obviously, that are very efficient for natural language processing. They're doing a lot of speech recognition work. So all these things and these systems. The question about Ciano. Does have support for FFT implementation of convolutional layers? Yes, it does. If you go to the Ciano resources that are course, or just go direct to deeplearning.net, then you can go through to /software, Ciano, library, tensor, and then we'll probably put these, I think, Q&As up online, hopefully, because that's as opposed to reading out web links. Ciano also supports CUDA, which obviously offers FFT convolutions since version 3 anyway. Question: are there some pre-trained model available based on Torch like Caffe? There is a module called Load Caffe that allows you to pull in all the pre-trained Caffe models. And as I said last week, bring in their own models, so you don't have to go to Caffe first of all. But you know, everybody's working on the same thing here. There's not real competition. It just depends on which flavour you want to use, so far as frameworks go. Feature-wise, are there any differences between Python tools? There are no Python binding to Caffe and Torch. There are many differences. So if you actually go through the previous webinars in the series, then you'll be able to pick up the major differences between Caffe, Ciano, Torch, etc. Again, go to the developer.nvidia.com. Just Google NVIDIA Deep Learning, and you'll go to the main site and have a look through. Spend a time investment on it, because the differences will become very apparent if you run through all those courses. Another question: how much of a speed up while training does Torch provide versus Ciano when running a deep net? It does depend on the neural network and the data and the hardware that you're using. There is no one size fits all for deep learning. There's lots of different variables in the user side, not just on the parameters. You can actually get some performance comparisons for convnets over on Sumith's GitHub. The CUDA convnet benchmarks CCN2 and Sander Dieleman, who's also now at DeepMind, spent a lot of time benchmarking the individual frameworks. So that's over at github.com/Sumith/convnet benchmarks, or you can just Google convnet benchmarks Sumith. Okay, is there an Android wrapper for Torch and Lua? Perhaps it's possible to run standalone Lua scripts but not easily get the data back into the app. Neither I nor my colleagues, I'm afraid, have tried that yet, but there's probably quite a few different Lua distributions that allow it. If you go to lua-users.org, there's a section on Lua distributions, and my colleague, also called Alison, says she actually found some interesting GitHub links for using Lua on mobile devices as well, which is mobile Lua. And again, everything's on GitHub. So github.com/divineprog, D-I-V-I-N-E, prog. Well, I think these Q&As will be going up, so it's a bit difficult to read out web links. But Android also has a port of Lua, and that's driven by a guy called Cotman. So you can actually just Google Andro Lua, A-N-D-R-O-L-U-A. There's also a link for a remote debugger that might be helpful, and that's by, just let me see. I mean, it's probably easier if you just scroll through the Q&As when we put those up, because there's a lot of links here for me to tell you. Okay, question, why is there a lack of enthusiasm for installation on Windows? To be honest, are primarily Linux. I might be wrong, but the lack of enthusiasm, if you're talking about last week's presentation, is simply because I've only ever done work on Linux besides any kind of deep learning on Windows. And I know from CUDA ConvNet, if you actually go through all the groups from Alex Krzyzewski's original framework, there's a lot of people that sort of struggled, and in the end just, you know, they all decided just stick with Ubuntu 14.04. So I was just going off that. You can try it, of course, if you're happier on Windows. Again, go to the Google groups. I'm sure there's some people trying it. Piano can be used on Windows quite well. It's perhaps a little bit easier, but Torch perhaps not. Question. Okay, the question is, the speaker said about working with medical images. So any resources for medical image segmentation? Yes, we actually just held our what's called a roundtable meeting in Germany yesterday, and I was lucky enough to be sat in the audience when Dan Sirasan from IDSIA was giving a demo on brain segmentation, and all his code, I believe, is available up on the IDSIA site. If you just Google Dan Sirasan, that's C-I-R-E-S-A-N, at IDSIA on brain segmentation. He's been working on that for quite a few years now, and some of the results are really spectacular. And they've been obviously working on medical images for a long time now, 6-7 years plus. So people.idsia.ch, again, it's all under Jürgen Schmidt-Huber. Dan was PhD for him. Can you post a link to the tensor theory? Okay, again, it's if you actually go to the slides on the developer zone, you can link to it. But there's also a Torch link via the GitHub. So github.com/torch will lead to the tensor theory, and also Jörg from DeepMind Ostrowski's tutorial. It's a really good one. Are there any tools or packages to debug Torch scripts? Yes, if you go again to Sumit's GitHub, so github.com/Sumit/ZBS-Torch, then there are lots there. Right. Okay, how are we doing for time here? Okay, I'm just going to go through on the chat, and I'm also just going to scroll up to the top and see if anybody else has been doing. I know everybody's been hard at work while I'm writing. Okay, a lot of people perceive Torch as a research scientific platform for deep learning. Is Torch also a good candidate for production use? Absolutely. in very active use. So where do we find more information on Torch deployment for production? Is Facebook or other big players using Torch in production environment? Yes, they are. Just one second. I have a pop-up that's currently blocking my screen now. Yeah, Facebook is actively using Torch, hence their involvement in this. Again, it probably depends on what you mean by production environment, but deep neural networks are constructed. Bear with me a second. Okay, can you please explain a little more? This is the question, sorry. Can you please explain a little more how Torch does automatic differentiation that is not numerical differentiation, but a technique to take exact derivatives without, yeah, I covered it, but there's a bit more detail here from a colleague of mine. So deep neural networks are constructed as a sequence of atomic operations, e.g. convolutional layers followed by applications. The NN module of Torch provides these atomic building blocks and knows the analytical solution for the derivatives of them. So that means that Torch can calculate the analytical derivative for the whole network through the train rule for differentiation. So the automatic differentiation isn't available for every function you can dream up, but it does cover all the commonly used atomic operations in today's modern networks. It was particularly beneficial for large neural networks due to the reduced error accumulation for repeated calculations. And the question, does the ARNO support automatic differentiation? And yes, it does. AD is almost necessary for large neural networks. My colleague Theo says that, my colleague Leo says that AD is baked in, just compute using gradient.grad. Is there a lot of focus on convolution, forward and recurrent nets? Are there any plans for doing work on improving recursive networks? Some of Soccer's recent work on language model. I believe there is in the Torch roadmap. This is a relatively new architecture, recursive networks. So they will be coming on board with that, no doubt, because there'll be people asking for it. Can you suggest normalization techniques? Okay, so dropout has shown to be a widely helpful technique, regularization. That's easily incorporated in Lasagna, which is Sander Deelemann's framework, using the dropout method and the NN package via NN.dropout. Nicholas Leonard is actually also making an open source package at his GitHub. And again, Nicholas is going to be holding an advanced webinar on October 8th. And again, there is a link in the original presentation, in the original Torch class, to sign up for that. So that's October the 8th. Okay, I'm going to run through some of the unanswered. Bear with me for 1 second. Right, I will use ImageNet datasets and evaluate deep learning algorithms. I'm trying to change some parameters to see performance of the algorithm. Can you suggest any tool that I can evaluate results and also techniques? I'm not sure what you mean by techniques, but if you can hang on for just a few more weeks, then we will have digits up and running. But let me see, changing the different parameters to see the performance of the algorithm. I would probably say to hang around until digits is fully integrated to help you. Some of my colleagues are just furiously writing while I'm speaking, actually. So for hyperparameter optimization, you can actually use HyperOpt is a package, John, and also Spearmint. This is real-time collaborative work. They will allow you to search across parameter choices. So HyperOpt, that's HYPEROPT, and also Spearmint. They also allow you to compare network performance. Thank you very much, John. Can you input 2 different image streams into Torch DNN to learn similarities? If you're planning to work on the basis of similarities and dissimilarities, then yeah, I mean, I'm assuming here that you're going to be using the RNN package as in the recurrent, because that is pretty much the basis. So assuming you're on the RNN Torch package. John's actually just given me GitHub as well for HyperOpt. So it's literally just github.com/HyperOpt. So networks, support, vector, machines, regression, etc. Would you advise me to pick up one of these systems and just jump into it? It seems you folks are most excited about Torch, saving the best for last. I do like Torch, definitely, but technically it's a tough decision to embrace a new ecosystem. It is, and I think that's probably why my colleagues in California, in HQ, decided to actually put this together just to help people make that decision a little bit easier. But it is really a personal preference thing. To be honest, it's like programming languages. You get comfy with one thing, and you can either try another one and see what works best, or it is also fairly reasonable to move in between Caffe, Piano, and Torch. So Leo is currently helping me to answer this one, and he's typing that honestly, for support vector machines and regression, scikit-learn in Python is the best way to get running. And for ConvNets, probably Torch for the ImageNet package. I personally was able to jump straight into the large data sets. Okay, I'm getting messages from my colleagues as well to say that we're probably about at wrap-up time, but getting back very quickly just to that last point, this is the reason I believe that all my colleagues have put so much time and effort into putting on series. It's so that you can get a good idea of the current most popular frameworks. That there are more and more frameworks coming out every day, and you know, it depends what you're actually doing out there, whether you're in production or whether you're just developing, etc. But if you run through all the classes, there was a lot of time and effort, I know, gone into those, and they're really worth it for the time investment. So at that point, I would just like to say thank you again for listening. I hope this entire webinar series has been helpful to you.
Hey, thanks, Alison. Yeah, I wanted to echo your statement that big thanks to the experts who put in a lot of time in addition to their normal day jobs to create this material and make it available for everybody. I'd like to thank all of you attendees who have been stuck with us for these 5 webinars over the last and the labs for the last 2 months. So thank you for joining. I encourage you to register for the OpenACC one if you have interested in doing directive-based programming on GPUs. It's going to be a similar style course starting in October and then going for about a month and a half or 2. And so again, thanks everybody for joining. I hope it's been useful. Again, the labs will be free for 1 more week, so get your lab time in now if you can before it starts costing a small amount of money to continue taking them. All right, thanks everybody, and bye.